Okay. Alrighty. So how long has it been since you've done some long division? A while? Okay. All right, so let's just start with a long division problem. So how about you guys give me a number that's, at least 3 or 4 digits long?
142.
142?
Yeah.
Actually, let's see. And how about we add a 3 to that?
Sure.
Make it a little bit longer. Okay, what do we want to divide that by?
Is it frozen? 8. It's not on the board.
It froze again. Oh. Okay, there we go. Okay, what do we want to divide that by? Did somebody say 8?
4.
No, I don't want it to be. Okay, we'll just do 8. Sounds good. Okay, so when we're doing long division, let me turn this off so we can see better. Okay, what would be our first step here? 8 into 14, all right? And we'd say, okay, 8 can go into 14 one time, so we put a 1 up here. And what do I do with that? You multiply it by the 8, all right? So we do the 1 times 8, and that gives us 8. What do I do with that 8? Subtract it. Okay. And I know some of you will only carry down one term at a time. I usually like to carry down everything because I don't want to forget. All right, now what do I do? Okay, and 8 will go into 62 7 times. And then what do we do with that 7? By the 8. All right. And what do? We subtract it. And I'll carry down that 3 again. All right. And what do we do here? Into 63 again. So again, we end up with 7. And again, we multiply that 7 by the 8. And we are left with, and what do we call that 7 if we're not going to continue on? We call it the remainder, okay? So we would say that our quotient is 177 and 7/8. Okay, so not out of decimals. All right, so basically, when we do our polynomial division, it's pretty much the same process that we're going to follow. Okay, slight changes because we're dealing with a whole polynomial instead of a single term, but you'll see the steps are all very similar. All right, so we've got f of x being a polynomial divided by d of x, our divisor. And of course, what's the rule? What's the only number you can never divide by? 0. Okay, so
you can divide 0 by something.
Yes, you can, but we cannot do something divided by 0. And we will get a quotient, which will be another polynomial, along with the remainder. Okay, so just like we did with the integer division, when we get the remainder, we just write it over that divisor. So we're going to do the same thing here. Okay. All right. So we're ready to try one. Enlarge that a little bit. Okay, so for our very first one, we've got 4x cubed minus 2x squared minus 10x plus 15, and we want to divide this by 2x plus 5. So one thing I want to pay attention to is that the dividend is in standard form with the highest degree first. Okay, and that we are going down in order by decreasing degrees. So in our dividend here, I've got an x cubed term, an x squared term, an x term, and then a term that doesn't have an x on it. That's like the x to the 0 term. So it's already put in order for us. And so just like we do with our integer long division, I'm going to start by placing that first. 4x cubed minus 2x squared minus 10x plus 15, and that is going to go under our fraction bar. And we're going to divide that by 2x plus 5. All right, so if you remember in our integer division, we looked at sort of the term that we were dividing by and to figure out how many times it would fit into the first couple digits of the dividend. So we're going to do the same thing here, except I'm only going to look at the first term because everything else will sort of build off of that. It's like a domino effect. Okay, so I'm going to look at first my 2x here and my first term over here, 4x cubed. And I'm going to ask myself, 2x times what will give me 4x cubed? It's 2x squared. Okay, so my 2x squared is going over here. And then remember what we did with our integer division? What did we do with the term that we wrote up here? You multiplied it, okay? Except we've got a whole binomial here, so we're going to multiply it to the entire binomial. So 2x squared times 2x plus 5. All right, so in distributing that, I get the 4x cubed, and that's the term we were after. And then 2x squared plus 5 is 10x squared. Okay. But recall when we did our integer division, what did we do with that term that we multiplied in? You subtracted. We do the same exact thing to this. We're going to subtract, so I usually just go through in one swoop and flip all my signs. Okay. And now I can just add my columns together. The 4x cubed minus 4x cubed, that was our goal in the beginning, was to get rid of that very first term. And now I've got negative 2x squared minus 10x squared. So that's negative 12x squared. And I just carry down all of my leftover terms. And now we are going to repeat that process. Okay. I'm going to look again at the first terms of the new line, however, now. So the first term is negative 12x squared, and again, I'm comparing the divisor of 2x. So same thing, asking myself, 2x times what is going to give me the negative 12x squared? Negative 6x. And we will write that on top here, minus 6x. And just like we did with our long integer division, I'm going to take that negative 6x and multiply it to the whole divisor. All right. So that gives me the negative 12x squared that we were after. And then we get the negative 6x times 5, so minus 30x. And again, what is it we did with that new line? You subtract it. So again, I'm going to flip all my signs. So that negative 12x squared plus 12x squared, that is now gone. And I have negative 10x plus 30x. So I've got 20x there. And I'm going to carry down my last term of 15. And guess what? Do we do it again?
Yeah.
Yes, we do it again. All right, so again, I am looking at the first term here and the first term in the divisor, and same thing, asking myself, 2x times what will give me 20x? And what's our missing term? 10. Okay, so I'm going to put in my plus 10 here. So I have 10 times 2x plus 5. All right, distributing that, that gives me the 20x that we were after, and then 10 plus 5 is 15. And don't forget, with that new line, we are subtracting. So I'm going to flip all my signs here. I have gotten rid of my x term, and now I'm left with 15 minus 50, negative 35. Okay. And now I look at this. Can 2x go into negative 35? It cannot. So what does that make that negative 35? That's the remainder. So just like we did with the integer division, I'm going to take that remainder and add it on up here. So it's going to become minus 35 all over 2x plus 5. And there is our final answer. Okay, what do we think?
It's so ugly looking. Look at it.
Is it ugly? I don't think it's ugly.
You didn't choose a very pretty color highlighter for those colors, though.
Oh, do we need a different color highlight? I don't know if we have. Oh, I think green will kind of blend in, though. Or I don't know. Maybe pink works?
Pink, yeah.
Let's try. Okay, I think there's a pink highlighter. We want to try that one?
Oh, no.
There's a light.
Oh, that's really hard to see.
You're right, you're right. Green.
Is there? I don't think I see a lighter pink.
Do like red.
You want to try blue? How about that one?
Well, we have a 6x.
Is that better?
I still kind of see the 6x.
Yeah, there you go. Yes.
Okay. All right. So let's look at another one.
Ooh, another one.
Okay. So this one is a little different here. And so we've got here, before dividing polynomials, the terms of both the dividend and divisor must be written in decreasing order. So that's what I stated earlier. That first one that we did was already set up for us, okay? But look at this one. Look at that dividend. What's going on with it?
Exponent of like the amount of exponents, so it would be 3x.
Yes, we want to start with the highest degree term. Okay, so that's the first thing I notice about this one. It is not in our nice standard form for us. So when I go to rewrite this with our division bar, I'm going to go ahead and put it in the order that we need it. Yes, Sherry? Yeah. Okay, so again, our highest degree term in this one is the to the fourth, so we will list that one first. So 3x to the fourth. Okay, and then I want to look to see, do I have an x to the third term? I do, and it is a minus 2x cubed. Do I have an x squared term? I don't. So since I don't have an x squared term, what I'm going to do is put in a filler for it. All right, so I'm going to go ahead and put in a plus 0x squared. Okay, and that's sort of a placeholder. All right, do I have an x to the first term?
Yes.
Yep, that one is 7x. And do I have an x to the 0 term?
20.
Minus 20. Okay, so now I've got it in the nice order that we like it in. Let me put my fraction bar up there and my divisor, x squared minus 3. Okay. So same thing that we did earlier. First thing I'm going to do is look at the first two terms here. Okay. X squared times what will give me 3x to the fourth?
3x squared.
3x squared. All right, and I'm going to multiply that. 3x squared by the x squared minus 3. Okay, distributing through, there's our 3x to the fourth. And what does that second term become?
9x squared.
9x squared. So do you see why it is handy to have that 0x squared in place? Okay. So I'm going to skip over the x cubed column and I'm going to put this right over here, 9x squared. Okay, so is it absolutely necessary that you put in that 0x squared, that you fill in? It's not. It's just, it's a nice reminder to not add together unlike terms, right? So if you put them in there, it's just a lot easier to see. Okay. What do we have to do with that line? Subtract it. So I'm going to go through, flip all of my signs over here. All right, our first column is now 0. Do I have anything to add to my negative 2x cubed? No. So we're just going to carry that down. And now I have 0x squared plus 9x squared. So that's 9x squared. And my last two terms don't have anything to add to them, so I'm just going to carry them down. And we start the process again. Okay, what should I be looking for this time?
Think 2x cubed.
Not just 2x cubed, but I heard Susanna say it. What's in front of the 2x cubed?
Negative.
Negative. Okay, we want to make sure that we match up our signs. Okay, so x squared into negative 2x cubed. And I just heard Susanna, so that'll be 2x. Okay, and just like we did before, I'm going to take that negative 2x and multiply it to the whole divisor. So there's our negative 2x cubed. And negative 2x times negative 3 will give me that positive 6x. So again, we're going to skip over this x squared term and add the 6x to the column that has the x variable. All right. And again, what do we do with that new line? Subtract it. And it's subtracting everything, so I'm going to negate all of my signs here. All right, nothing to add to the x squared term, so we carry that down. And now I have 7x minus 6x. So that'll be plus 1x minus 20. All right. And do we do it again? Yes. All right, so again, this time we are looking at x squared into 9x squared. So what are we going to have to multiply by? 9. So plus 9. We get 9 times x squared minus 3. We'll distribute that through. 9x squared. And that's minus 27. And don't forget to subtract. And again, make sure that you flip all those signs over. Okay, nothing to add to the x term, so we carry down. And now I have negative 20 plus 27. 7. All right. Yes?
Why is it just
Why is it... Well, because why is it just 9 up here? Is that your question? Okay, because when you multiply the 9 by the x squared, you get 9x squared. And that's the term that we want to subtract out. Now, does x squared fit into x?
No.
It does not. So what does that mean the x plus 7 is? That's the remainder. And so we just come right back and add it up here. It's x plus 7 all over x squared minus 3.
Can we simplify that or
No. This one will not simplify further.
no?
Okay.
Are there problems that will simplify further on the subtraction bar? Not subtraction bar,
Not in these, because if they simplified further, you would have seen it in the division process.
cool, yeah, that's good to know.
Okay, I'm trying green. How's green?
I like some
Hunter green?
whichever one you did before. Try to. Wait, what happened?
We tried. I don't see hunter green. Do we try pink this time?
Whichever one you did before.
That's really dark, isn't it? I did yellow first, but
Oh, I like that. Go to colors.
okay. Okay. I like the yellow. All right, here is one for you guys to try. All right, so should have gotten squared plus 2x plus 4. Okay, did anybody run into any problems with this one? I saw a couple sign errors. I know not everybody put those fillers in, the placeholders for the missing x squared and x term. Again, that's perfectly fine. It's just make sure that you don't add the wrong columns together. Okay. All right. Ready to look at synthetic division?
No. Well, let's go.
Synthetic division is awesome. It is awesome, awesome, awesome. Yeah. Yeah. Okay. So synthetic division, yes.
That's one question for the I got it at like a -1 like the last.
You got a subtraction instead? You got -4?
Yeah.
Okay. Are you talking about on this problem here?
Yes. No, I didn't got -4. I got so the last one we got at the very last x plus 7, and so we added x plus 7 to the x squared -3, and I got -24.
Right. So synthetic division it's really fast. It's a really nice technique to use. The only thing is you can only use it when your divisor is in this form here. Okay. And I mean, I guess technically you could say x plus or minus a. Okay. So the problem that you just did on your own, could we use synthetic division on that one?
Yes.
Yes. How about the one that we did that with before? No, it would not work because there's a square term in there. Okay. So again, as long as you're only dividing by a divisor in this form, then synthetic division is super fast. Okay, so in order to do synthetic division, things we want to pay attention to. Again, number one, the divisor needs to be in this form here. And so what we do is we look at the divisor and we say, okay, well, if x minus 3 is equal to 0, what would that mean x is equal to? It means x is equal to 3. So what I'm going to do is just take the 3 and I'm going to put it here and I'm going to put it in its own little box. So again, with synthetic division, what happens is we don't use all the variables. We only use the coefficients with them. So the next thing is, I'm going to look at the dividend, okay? And just like with the long division, I need it to be in standard form with the highest degree term first, okay? So I look at my dividend, and what is the highest degree term? X to the 4th. What is the coefficient on x to the 4th? 1. So that's all I'm going to write in the first position is 1. And now I need to go down in order of decreasing degrees. Do we have an x cubed term? We don't. So I'm going to put in a 0. Now remember, I said in the long division, you didn't have to fill those in, but in synthetic division, you have to. You've got to put that 0 in place. Okay, do I have an x squared term? Negative 13. Do I have an x to the first term?
Wait, how did 0? Oh, yeah.
Okay. And my constant, or x to the 0 term, is 32. Okay, and now what I'm going to do is leave space down here, and I'm going to put a bar there. Okay. Now again, this is like the polynomial long division. Each new step builds off the previous step. Okay, so when we start this one, the first term always just carries down. And then now what we're going to do is look at the term that we get down here, and we multiply it by what's in the box. So 1 times 3 is 3. We're going to put that 3 up here. And now I'm going to add that column together.
Wait, why did you put the 3 right there?
Because that's where it goes in synthetic division. Because now I'm going to add the column. 0 plus 3 is 3. And just like we did in the previous step, I'm going to take this 3 and multiply it by what's in the box. So 3 times 3 is 9, and that 9 is going to go here in the next column.
Okay, I'm sorry, I'm confused. How did we get the first 3, the green 3?
By doing 1 times 3. 1 times 3 is 3. That 3 came over here, and then we added 0 plus 3 to get 3. Right. So now I have negative 13 plus 9. What does that give us? Negative 4. Okay. And what do I do with that negative 4? Multiply it by what's in the box. Negative 4 times 3 is negative 12. Where does that negative 12 go? Under the 0. Now I have 0 minus 12.
Wait, how did you get
Negative
negative 4?
Negative 13 plus 9. You just add the column together. What's in the column? Okay, so now I've got negative 12. What do I do with that negative 12? Multiply it by the 3 that's in the box. Negative 12 times 3, and that's negative 36. So where does that negative 36 go?
Under the 32?
Under the 32. And now I add 32 minus 36 is negative 4. Is there anything left? There's nothing left. We have reached the end. And so what happens now is the last column is the remainder. And then it just goes in order from there. This is the x to the 0 term. This is the x to the first term. This is the x squared term. This is x to the 4th. So now I'm just going to put it all together. I have 1x to the 4th. That's x to the 4th. I have 3x squared plus, oh, sorry, thank you. I lost track. X cubed, thank you. X cubed plus 3x squared. I have minus 4x minus 12, and then how do we write our remainder in?
Negative 4 to 3.
Yes, minus 4. Because we took an x to the 4th term and divided an x. So it's like having x to the 4th over x will give us an x cubed. Okay.
We need to do another one of these because
We're going to. Yes, Al?
Is this one of those things that that'll like be on a test? Or is that a matter of like preference?
You might specifically be asked to use synthetic division, but you want to know it because what happens every year when you get onto a higher level of math?
bad things.
Not bad things. Are you building on it all the time?
Yeah.
Yes. Okay, so you may have some multi-step problem in a future math class, and within that multi-step problem there is a small little polynomial division problem, and you don't want to spend a whole lot of time on it. You want to be able to work that step out quickly. Oh no, watch. We're gonna do a quick one. Yes, right.
How do you get
So
the
slow, though,
first
so
line, like 1, 0, minus 30?
You use the coefficients from your terms up here. So that's the 1. We don't have an x cubed term, so that's why we have like a 0x cubed. This is the negative 13. We don't have an x term, so that's why we have a plus 0x. And then that's the 32. Okay. I'm going to do another one with you guys, and I'm not going to write out all of these steps. Why do I have so much space built in here? Let's move this up some. Okay. So hopefully you guys noticed that. The quotient is going to be 1 degree less than the dividend. Okay. The result that you get from doing the division. Right. So 8 divided by 4 is 2. 2 is the quotient. Okay. So let's look at this one. All right. And I'm not going to write every step out in this one. We're just going to kind of go through it a little bit quicker. So again, can we use synthetic division on this one? Yes, because this is an x minus 3, which means what is my x equal to? 3. So again, we'll put 3 in the box.
Why is x equal to 3?
You kind of think of this as a 0. If you do x minus 3 equals 0, that means x is equal to 3. Okay. Alrighty. And again, I need to look at my highest degree term. What's my highest degree term? X to the 4th, and the coefficient on x to the 4th is 1. So we do 1. Do we have an x cubed term? No. So we put in a 0. X squared term? Negative 10. X to the first term? 2. X to the 0 term, or the constant? 3. Okay, so I'm not going to write all the steps out this time. We're just going to sort of do this a little bit quicker. 1 carries down. Remember, first term always carries down. Okay, and now I say 3 times 1 is 3. 0 plus 3 is 3 times 3 is negative 10 plus 9 is negative 1. 3 times negative 1 is 2 minus 3 is 3 times negative 1 is 3 minus 3 is 0. So do you see how quick and efficient synthetic division can be? All right, so the fact that we got 0 at the end, what does that mean?
No remainder.
There's no remainder, which means that x minus 3 is a factor of this dividend. Okay, so we have no remainder. Again, that's the r. This is the x to the 0 term, x to the first, x squared, the x cubed term. And now I'm just going to put it all together. I have 1x cubed plus 3x squared minus 1x minus 1, and no remainder.
What happened to the x to the power of 4?
It was divided.
Oh.
Yeah, because we divided an x out.
So why is it called synthetic?
Yeah, because we're not including all these all the variable values. I don't know why they call it synthetic exactly. Okay, so I'm gonna let you guys do the last 2 on your own. There you go. All right, so it looks like most of you got a 4 down. How many of you got nervous with those numbers? I heard, just thought it was wrong.
They're so big.
But that happens sometimes. And then our last one, x cubed. So again, what does it mean if you have no remainder?
It's
What you're dividing by is a,
perfect.
it means it's a factor. It's a factor. Yes, connections, that's right. Okay, So that's all we have today. Let me see.